Some people put this as the answer, 3 greater than x. Mathematically, nothing wrong, but presentation-wise, when you ask to solve the inequality, when I ask you to solve an equation, will you write down 3 equals to x, or will you write x equals to 3? X equals to 3, right? Nobody will write 3 equals to x, isn't it? So same thing, we put an unknown first, x less than 3, instead of 3 greater than x. Okay, just a small point over here to make.
But you count as wrong.
No, it is not. But it's just that nobody does it that way, okay? Now, part B, solving simultaneous inequality. Some of you lost marks over here when you divided both sides by a negative number. So you divide by a negative number, the sign has to flip. So a few people forgot about that, and therefore you lost marks over there. So x is supposed to be greater than negative 4, but it is less than 5. So it is bounded by negative 4 and 5. So as shown over here, the last answer. Okay, next. Find the smallest possible value of 2x plus 3y. We did quite a few examples on this already. To find the smallest possible value, I need smallest x plus the smallest y over here lah. So the smallest x in this case will be 2, because x cannot be equal to 1. Some of you put 1 over here, so you get the answer wrong. So the answer should be negative 20. Okay, next one, part 2. Greatest possible value of x squared plus y squared. I want the greatest value. So I must have the greatest x squared. I must have the greatest y squared. Let's take a look at x. It ranges from 1 to 6, including 6. So the largest obviously is 6 squared. But the problem comes in y squared. Some of you just chose 25. 5 squared is 25. But you forgot that, hey, actually I can choose negative 8. I square it, I get 64. Isn't that a bigger value? Should get 100. Any questions?
No.
Next, triangle length. So there is only one criteria given to you. That is, the perimeter is less than 50 cm. So obviously the 3 sides you add up must be less than 50 lah. The moment you write this down, you get 1 mark already. Most of you got it. You managed to get x less than 9.6. Yes, you get 2 marks. The problem comes when they ask you to find the possible values of x. You thought it is so simple. It must be 9, 8, 7, 6, 5, 4, 3, 2, 1. Cannot be 0, right? But in the first place, can it be equal to 1? Why the length why can't x be 1? I start inside here. 2 times 1 plus 7. 10 what? That's 9, right? I start inside here. 1 plus 4.
5.
Sounds reasonable, 5. I start inside here. 2 times 1, that is 2 minus 9, negative 7. Can x be 1?
No.
Cannot. So the restriction lies over here. This length over here must be greater than 0, right? You can't have a length that is less than 0. You can't have a length that is 0, in fact. So in this case, 2x minus 9 has to be greater than 0 as well. 2x must be greater than 9. X must be greater than 9 over 2, which is x greater than 4.5. That's why the smallest value of x is 5. Get it? So must use some common sense. You think you get this part, you got the correct answer already? Not yet. You need to start back inside to see whether everything makes sense or not. Okay, so you lose an answer mark over here. Okay, next. Proving that these two triangles are congruent. Okay, so this is the answer given. Let's take a look. AB equals to AC. Is that given to you in the question? Is that given? AB equals to AC? So you just write AB equals AC, then don't need to write isosceles triangle. It's just given. Now AE equals to AF. Is that also given?
Yeah, it's also given.
Did they say that AB equals to AC
Yeah.
in your question?
Yeah.
Then did I penalize?
No, but then you put
You
isolated.
didn't, like, put the parrot, then isosceles.
Okay. Sorry. It is also given that AE equals to AF. So I have already got two lengths being the same. A to C, A to B. Then I've got AE and AF. Okay. Next one. They also give us BAE equals to CAF. That is a common angle. BAE, CAF. Yeah, it's the common angle, right? So by this, based on these three evidence, I've got a side angle side where the angle is included. Do you all agree? Therefore, they are congruent. Okay, ABE and ACF. Now, the common mistake is that many of you assume that. What did I write over here? Number of you made, you assume that ABE equals to ACF. Is that given? ABE, ACF. No, nobody said that they are the same. So whatever reason you're going to give me is nonsense. Likewise, you assume that BE equals to CF, which is not given to you. So if you are unable to prove it, you cannot use it as part of your evidence. You only can use what you can prove, shown over there on the tree, for the tree. So any questions for this one? Nana? Next, show that triangle BCD is isosceles. In order to show that a triangle is an isosceles triangle, there are two things that you can prove. What are they? What are the two things? Lucas? Either the two sides are the same, then it's isosceles already, right? Alternatively, we can prove that two angles are the same. In this case, we are going to try proving that two angles are the same. Okay, so in for this angle, ABE and ACF. ABE, ACF. Yeah, they are the same angles because earlier on we've already proven that those two triangles are congruent. So corresponding sides of corresponding angles are the same for congruent triangles. Next one, ABC and ACB, they are the same. Because it is given that it is an isosceles triangle. Okay, so to complete this, you should be writing base angles of isosceles triangles. Okay? So since these two angles are really the same, then we're going to find a difference. Find the difference between those two angles and you will still get the same result. Because you're subtracting away the same angle from the same angle. Therefore, proving that angle DBC is the same as angle DCB. Okay, any questions for this? By the way, you better do your corrections properly because when school reopens, I'll be giving you all the same questions again. That is your homework for this weekend. You make sure you are able to do the same paper and get full marks for both A-Maths and E-Maths. Because quite a number of you are not doing your homework. I'll be giving you the same paper again. If you don't get full marks, you do again. You do and do until you get full marks on the same day. You stay back with me. Okay, can I move on to C? Who needs more time? Okay, now moving on to part C. Show that these two triangles are congruent and prove the congruency. State a triangle that is congruent BDF. Let's take a look. BDF. Based on this diagram, right, quite obviously you can tell that C, D, E must be the triangle that's congruent, right? From the diagram you can tell already. But how do you prove that they are congruent? So in this case, we can use the ASA test. I think it's next question. Prove that the two triangles are similar. What is the easiest way to prove that triangles are similar? Yeah, triple A, your angle similarity test. Most of the time it will work. Let's see whether it works over here. Okay, so they already gave you that angle ABC, angle EBC. They are the same. Okay, write down the first one, given. Another angle, there is a common angle, ACB as well as ECD. It is the common angle over here, same one. So since two angles are the same already, I told you to include a third angle. The last angle equals to whatever angle. Put in an angle sum of triangle, and then quote the angle similarity test. You're done. You get a full 2 marks. So some of you tried to find a ratio of sides over here. It's redundant. You can't use the ratio of sides to help us in this case, unless you have two sides. So you can use the SAS similarity test. There's no such thing as ASA similarity test. Okay? Because once you have two angles, then you have the third angle already. Then that should be our angle similarity test. You get it? The next one. Part 2. Find the length of AD. Many of you only managed to get 1 mark over here. So just find the corresponding sides. Ratio of the corresponding sides. In this case, AC on this side, the naming of the triangles, AC. It has a corresponding side to EC. So find EC. Where is EC? EC is over here. So the blue color ones, AC over 4. That's what we have. Okay, then you find another ratio of sides. Another pair. So in this case, we've got AB. AB over here. Okay. A to B. The corresponding side must be E to D. E to D. Oh, we have that also. 18 over 6. So based on this, algebraically, you can solve for AC, which is 12. AC is 12. Therefore, AD must be 12 minus 8, you get 4. So 2 marks for this. And finally, for part 3. Area of triangle ABC is X. Find the area of ABDE. ABC, the entire one. The entire area is X. Then we've got one triangle inside another triangle, right? What is the ratio of sides of the small triangle to the big triangle? Ratio of side? 1:3. Okay, we got that from 6 and 18, isn't it? So if the area for this small triangle, if it is 1 square unit, what is the area of the big triangle? 3 square, which is 9. If the area of this small triangle is 2 square units, what is the area of the big triangle? If the small is 2, what is the area of the big one? Huh? What is the ratio of the side again? 1:2? 1:3. So what's the ratio of area? 1:9. So if this is 1, then the big triangle must be 9. If the small is 2, then the big one must be? Do you all get it? Big one must be 18 lah. If the small one is, for example, 10, what is the area of the big triangle? 90. Just multiply by 9, isn't it? Right? Okay. So now if the small triangle is 10, the big triangle is 90, what about the quadrilateral? Because 90 minus 10, you get 80, isn't it? Simple, huh? What if I tell you that the area of the big triangle is 18? For example, area of the big triangle is 18. What is the area of the small triangle? 2. Why? 18 divided by 9, you get 2. So how must this be? 16. So if I now tell you that the area of the big triangle is X, then what is the area of the small triangle? 1/9? X. 1/9 times X, or rather, this will be X over 9. Then what must this quadrilateral over here be? X minus X over 9, which is 8X over 9. X over 9 times 8, same thing lah. 8X over 9 lah. Generally okay for this. For the two bottles that are geometrically similar. So for geometrically similar objects, the ratio of area, regardless of what kind of area I'm talking about, whether it's the base area or the curve area or the top area, side area, as long as I'm talking about the same area, the ratio of area must be the square of the ratio of sides. Agree? Then what about the ratio of volume? Cube of the ratio of sides. Now, they give us the ratio of volume, 400 ml to 1350 ml. So you have the ratio of volume. You should therefore be able to find the ratio of the height by taking the cube root. Okay, so the common mistake is that you thought the ratio of length is the ratio of volume, which I repeated so many times it is not the same. And obviously people will make this mistake. In the next question, they also make the same mistake. They think that the ratio of area is the same as the ratio of length. But remember, we investigated this. I drew all the shapes, all the circles, the squares. We found out that the ratio of sides is not the same as the ratio of area. So here are the answers. The easiest question of the paper. Write down the equation of PQ. Very badly done. Y equals to 7. All sorts of answers given to me. PQ is a horizontal line. It's Y equals to 7. Now, class, tell me, what is the equation of this line? This red line? Y equals to 5. Easy or not? What is the equation of this line? Is it 2 or Y equals to 2? Okay, what is the equation of... What is the equation of this line? Yes. Okay. Now part 2. Quite well done. Find the equation of QR. So find the gradient. Substitute in the set of coordinates. Find the y-intercept. Part 3. Decent. You just substitute in the x and y coordinates. In this case, it is a and a minus 2. Solve for a. That's it. Okay? So 15 units. Part 5. Instead of using half times base times height, some of you chose to use the shoelace method. If you did it correctly, I will still give you the mark. But it's just a waste of your own time. Part 6. Finding the perpendicular distance was quite well done. And part 7. Finding the coordinates of S if PQSR is a trapezium and PQ is parallel to RS. Okay, you can copy this down. It is basically just the formula for the area of trapezium. Half times sum of parallel sides. In this case, the parallel sides, we've got RS as well as PQ. And PQ, the length is 4. Multiplied by the perpendicular height, 12. So RS being 10 units, go back to your diagram, find where the coordinates of S are, given that RS is 10 units. Yes?
I thought this question